Right, if you haven't figured it out, this whole unit's going to be about right triangles, that kind of fun stuff. This happens to be altitude on hypotenuse theorems. This is 9.3 in your books. Here's a funny joke for you. What do you call a bathroom that's occupied on the top floor of the Willis Tower? A hypotenuse. Yeah, anyway, that was really bad. I'm sure you're all groaning right now. Anyway, our objective for today: to identify the relationships between parts of a right triangle when an altitude is drawn to the hypotenuse. Alright, so when an altitude, CD, is drawn to the hypotenuse of triangle ABC, three similar triangles are formed. Triangle ABC, triangle ACD, and triangle CBD. Alright, so we're going to say that triangle ABC is similar to triangle ACD by angle, because they both have this angle here. They're both right triangles because it's an altitude, remember. Okay, and this is just, I know it's smaller, I'm just kind of showing you here. So we would have angle because they both share the right angle, they both share this. So there'd be angle. Notice the corresponding labeling though. Okay, they both start at A because that's the angle they share. But for the big, or for the small one, I'm going to ACD, so I'm ending up at the right angle. Starting at the similar angle, the congruent angle, if you will, and ending up at the right angle, which means for the bigger triangle here, I'm going from A to B to C. Okay? So we can create a proportion from that. Since the triangles are similar, we can say AB corresponds to AC, and that ratio is equal to the ratio of AC to AD. Or, if you did your cross multiplication, you would say AC squared equals AB times AD, which means that AC would be the mean proportional between AB and AD. How is that going to help you? You'll find out in a minute or two. Anyway, let's move on to the next pair of similar triangles. We've got ABC and triangle CBD, again, by angle, because they share that angle. And everything corresponds again, and that gives us this proportion. AB over CB, because we've got AB right here, the hypotenuse, and CB, which is the hypotenuse of the smaller triangle. And then CB over DB. Okay? And again, same thing. CB squared equals AB times DB, which means that CB is the mean proportional between AB and DB. What does all this mean for you guys? You'll see. I promise. I know it's confusing, so take notes the best you can. But don't worry about it being too detailed yet, because I will show you this in an easier way. Probably should have told you that on the slide before. Alright, so if we've got these two triangles, okay, we can say that triangle ACD is similar to triangle CBD by transitivity of similar triangles, which creates a proportion. Again, we've got AD from the similar angle to the right angle is the ratio of AD to CD equals the ratio of CD to DB, or CD squared equals AD times DB, and therefore CD is the mean proportional between AD and DB. Okay, the main thing we're taking from all this is that this part right here, that's the mean proportional. I'm going to change it in color here. Okay, because remember when we did geometric mean. Okay, keep that in mind, because remember some of the theorems that go along with that, because I don't know for sure, but I have a feeling that they might be used in this unit a little bit. Alright, so rather than write this as three separate theorems, we're going to keep it as one. Now I got my diagram down here, and I know it's way down here and kind of in the corner, but rather than talk about this as AC, AB, so on and so forth, we're going to use these smaller letters to keep it a little bit simple. So this is Theorem 68. All of these are part of Theorem 68. If an altitude is drawn to the hypotenuse of a right triangle, so remember the altitude goes to the hypotenuse, and the hypotenuse is the part that is opposite. It's the side that's opposite the right angle. So when we take that line from the right angle to the hypotenuse, which creates another right angle, we can say the two triangles formed are similar to the given right triangle and to each other. So all three of these triangles are similar. This one, and the big one. All right. That the altitude to the hypotenuse, this right here, is the mean proportional between the segments of the hypotenuse. Okay, and I'll get to what that means in just a second. And yes, you can shorten parts B and the next part. So in this case, this h squared equals x times y. So whatever that altitude, however that's dividing up that segment, that's the mean proportional between the two. All right, C says either leg of the given triangle is the mean proportional between the hypotenuse of the given right triangle and the segment of the hypotenuse adjacent to that leg. So for example, we can say that b squared, okay, this, remember, the segment that's split by the altitude, excuse me, and this entire side, or this one would be the mean proportional between this and, again, this entire side. So hopefully that helps a little bit, clears it up. And for like part A, you'd have to write out the whole thing. For part, B and C, for B, you could say Theorem 68 and then just do that. For C, you could say Theorem 68, either one of these. But a lot of times you're just going to be using this in a mathematical sense rather than in a proof. So just something to keep in mind. It's going to have to be something you memorize, so you might want to write it down somewhere, highlight it, so when you're taking your quizzes, you have it somewhere and you don't have to go hunting for it. So highlight that part, circle it, underline it, do whatever you got to do. So let's do a practice problem. We have that segment AD is 3 and segment DB is 9, and we can tell because of this that this larger triangle is a right triangle and this is an altitude because that's a right triangle. So we're going to use what we know. Okay, CD squared equals AD times DB, and we're just going to plug in 3 and 9. So x squared equals 3 times 9, so x squared equals 27. So to get rid of the x squared, we square rooted both. Square root of x squared is just x, which is how I got that. Square root of 27 is the same thing as square root of 9 times 3, and of course the square root of 9 is 3. So we could say x equals plus or minus 3, but that is not the answer. Okay? We say CD equals positive 3 times the square root of 3 because we have to disregard the negative. We can't have a negative measurement. With this diagram here, since we have a diagram, we know we're talking about a measurement. So for pretty much most of these in this unit, you're going to be disregarding the negative unless it is just an equation. If they're not referring to a shape or in a word problem, that kind of thing, it's always going to be positive. If it's just strictly an equation, that's a different story. Then you do the plus and the minus. Okay? Again, CD cannot be negative, so reject the negative 3 times the square root of 3. All right, let's change it up a little bit. So let's say that DB is 21 and AC is 10. Find AD. So we know some different parts this time. Okay, we say that AC squared equals AD times DB. So now we have AC and we're missing one of the other parts. Okay, so we're going to call that X, and then this whole segment here would be X plus 21, right? So we get 10 squared equals X times X plus 21. Distribute that X and simplify this, so you get 100 equals X squared plus 21X. Okay, you're ending up subtracting that from both sides. Remember, no x, so we can't do anything with it there. You get x squared plus 21x minus 100 equals 0. So to factor this, you would have to make your x, okay, positive 21, negative 100. That means that one number is negative and one's positive when you have a bottom number that's negative. So you got to think about factors of 100, negative 100, that would add up to a positive 21. So the smaller number would be negative. Well, I'll save you the time. It's negative 4 and positive 25. So you do x minus 4 and x plus 25, okay, equals 0. Split those up so you have x minus 4 equals 0 or x plus 25 equals 0. You have to add 4 to both sides here. Subtract 25 to both sides here. Those cancel out. You get x equals 4 or x equals negative 25. But again, remember, we're talking about a measurement. So we reject the negative 25. And we're left with AD equals 4. So this segment here equals 4. Okay? So again, you kind of get an idea as to how it's being used. Actually using it's a lot easier than explaining it. So once you get used to it, you'll be fine, trust me. Just remember, it's always going to be the part that's, adjacent, and then the part that's the whole. That's the key right there.